Hello guys, I'm Ayswarya. Welcome to Ayswarya's Math Classroom. In this video, we are starting ninth grade chapter 1 number system. This is an introduction video where I will explain the concepts and solve some textbook examples. This will help you understand the chapter clearly and solve the exercises easily. Exercise questions will be covered in separate videos. So, let's get started. Number system. First, let us discuss the different types of numbers. As you can see, natural numbers, whole numbers, integers, rational numbers, irrational numbers, real numbers. What are natural numbers? The numbers that starts from 1 and go upon up to infinity. They are also known as counting numbers. That means 1, 2, 3, 4, 5 till infinity. This type of numbers are known as natural numbers. Okay, it will start with 1. Next, whole numbers. Whole numbers are set of natural numbers along with 0. That means this number starts with 0, then 1, 2, 3, 4, 5 till infinity. So natural numbers it will start with 1, whereas whole numbers it starts with 0. Next, integers. Integers are whole numbers that include all positive numbers, negative numbers, and 0. That means it has positive numbers like 1, 2, 3, 4, 5 till infinity. Then negative numbers negative 1, negative 2, negative 3, negative 4 till infinity. And it has a 0 also. Okay, 0, then 1, all the positive numbers, then negative numbers. See, if you look here, this one 1, 2, 3, you can see that also as here in natural numbers. So we can say that natural numbers are also positive integers. Okay, so I hope that is clear. Next is rational number, which is very important in this chapter. We have many exercises to do with this rational number. So let us see what are rational numbers. These numbers can be expressed in the form of p by q, where p and q are integers and q not equal to 0. That means by this definition itself, we must have understood that then the numbers are expressed as fractions. If you take example like 2 by 5, 4 by 7, then again 1 by 3, negative number as well. These are all written in the p by q form. Okay, and where p and q are integers, and here q is not equal to 0. The q shouldn't be 0. So these numbers which are expressed in the form of p by q are known as rational numbers. Next, irrational numbers. These numbers cannot be expressed in the form of p by q. So the example we can take as root 2, root 3, root 5, even pi. All these are examples of irrational numbers. These numbers cannot be written in the form of p by q. Next, real numbers. It contains both rational and irrational numbers and can be expressed on a number line. That means if you draw a number line, see in previous grades also you have must have studied this, right? Drawing a number line, on the right side you have the positive numbers, then left side negative numbers. So all this you have studied in your previous classes. So all these numbers like which are expressed on a number line, they are real numbers. That means if you combine both rational number and irrational number, then it forms a real number. Got it? So in this page, we discussed about the types of numbers, and I hope everything is clear for you. Okay, now let us go to the next page. See, here are some questions related to the types of numbers. Are the following statements true or false? Give reasons for your answer. See here, every whole number is a natural number. Every whole number is a natural number. Actually, the answer is false. Why? Because 0 is a whole number, but not a natural number. So we can't say so every whole number is not a natural number because 0 is a whole number but not a natural number. Every integer is a rational number. Every integer. Okay, this is true. Why? If you take any number, okay, here let me take m. If I'm taking this as a number, this can be expressed in the form of m by 1. So this can be written in the form of p by q. So every integer is a rational number. Okay. Next question. Every rational number is an integer. Every rational, it's false. Why? If I take a number 3 by 5, 3 by 5 is not an integer. I hope this part is clear. Now let us go to the next page. Rational numbers. These numbers can be written in the form of p by q, where p and q are integers and q not equal to 0. Okay, this I have already discussed in the first page, right? Rational numbers. So first, let us find this one. Like find 5 rational numbers between 1 and 2. If you get a question like this, it's very easy. See, they have asked 5, right? So when they ask a number like this, 5 rational numbers or 4 rational numbers, you take the next number. Like, see, first write 1 here, then leave some gap, then put 2. For 5, they are asking multiply this with 6 and divide by 6. Like, write it like in the p by q form. And here also 6 by 6, which is equal to 6 by 6, and this will become 12 by 6. Now see, you have to write the 5 rational numbers between these two fractions. So what will be there? 7 by 6, 8 by 6, 9 by 6, 10 by 6, 11 by 6. So these are the 5 rational numbers between 1 and 2. It was easy, right? Okay. Now let us see the next question. Next one is find 5 rational numbers between 6 by 5 and 7 by 5. In this one, if you see, the denominators are same. If the denominators are same, we don't have to do anything. We can directly like multiply with, like I said, if it is asked 5, multiply by 6 by 6. But here also same. That means whatever number you are taking, you have to multiply on the numerator part and the denominator part. Okay. Then 6 into 6 will give you 36 divided by 30. And this is 42 by 30. And we have to write the 5 rational numbers between these two. That means 37 by 30, 38 by 30, 39 by 30, 40 by 30, and 41 by 30. So these are the 5 rational numbers between 6 by 5 and 7 by 5. I hope this was easy for you. I hope you all understood. Now let us go to the next page. Now see, find 4 rational numbers between 2 by 5 and 3 by 4. If you look at the denominator part, the denominators are different. So you have to make the denominator same. For that, we'll take the LCM. Actually, you don't have, you can directly write, it's very easy, but I'm showing you like this. So if you take 2 here, this will become, then again 1, then 5. Okay, the LCM you will get here as 20. Now, to get the denominator as 20, with what number you multiply, you will get 20. You have to multiply it with 4, you will get 20, right? So when you're writing 4 here in the numerator part also, you have to write 4. Same way over here, to get denominator 20 over here, with what number you have to multiply? You have to multiply it with 5. And when you're writing here, put the 5 on the numerator part also. So here if you see, this will become 8 and this will become 15. So we have to write 4 rational numbers between 2 by 5 and 3 by 4. That is 9 by 20, 10 by 20, 11 by 20, 12 by 20. So these are the 4 rational numbers between 2 by 5 and 3 by 4. I hope you understood. When the denominators are different, you have to make it same. So for that, you have to find the LCM and then do the normal way how you do this. Okay, now let us go to the next page.
Irrational numbers. Show rational numbers on a number line. Irrational numbers means like root 2, root 3, root 5. We should represent this in a number line. So these questions are very important and it will be sure for your exam. This I will do in a separate video. The links to this video will be in the description box. Please do check it out. So let's move to the next page.
Real numbers and their decimal expansion. Find the decimal expansion of 10 by 3, 7 by 8 and 1 by 7. Okay, the first one, 10 by 3. We just need to do the normal division. That is 3 threes are 9. When you subtract, it becomes 1. Put a decimal point, it becomes 0. Then again 3, 9, 1 again, then becomes 10. Put 3, then you have 9. So in this, you can see that it is repeating. See, it is repeating here. It again goes, you can see 1, it will again keep on repeating. So this type of decimal expansion is known as non-terminating and repeating, because it does not stop here. If you look, the remainder does not become 0. It keeps on repeating. So this type of decimal expansion is known as non-terminating repeating. Okay, next one, 7 by 8. Put a decimal point here, it becomes 70. 8 8s are 64. Subtracted 60, then 7, it will become 56. This will become 4. Okay. Now see, in this case, the remainder becomes 0. The remainder becomes 0 and it stops. So this type of decimal expansion is known as terminating decimal expansion. Okay, it's terminating. It stops when the remainder becomes 0. It stops, and in this type of decimal expansion is known as terminating. Next one, 1 by 7. Put decimal point. This becomes 10. Then put 1. Okay. Then 4. This becomes 28. Okay, 2. It 14. 60. Then 8 becomes 56. 4. Then 5. 35. Then 7. 49. 1. At this particular point, you can see that the 1 is again getting repeated. From this point, it starts, from this point, it starts repeating. So, this type of expansion. So it keeps on going from a particular point, it starts repeating. So this is again known as non-terminating repeating. Again, one more important thing. See, if you get a number like 10 by 3, and if the decimal expansion is non-terminating repeating, you can say that they are rational numbers. See here, it's non-terminating, it's repeating. So this cases you can say that they are rational rational numbers, and it can be represented by r. Next one, again in this case where the decimal expansion is terminating. hmm, This also, this type of decimal expansion are also rational numbers. So rational r. The next one, again the same thing, that is non-terminating, then repeating. This also, this type of decimal expansion, these numbers are also rational, represented by r. Now if you take like look at irrational numbers like root 2, root 3, root 5, then number like pi, which we take it as 22 by 7. If you take these numbers and do the if you take the square root of these numbers, which you have studied in the previous class in 8th, you have studied how to do the square root of these numbers. So if you do that, in that case you can find the numbers like non-terminating and not repeating. Okay, because it will continuously keep going and the numbers won't repeat. So this numbers which are non-terminating and non-repeating are irrational numbers. Okay, and it is represented by I. So let us move on to next page. Show that 0.3333 etc. is equal to 0.3 bar can be expressed in the form P by Q, where P and Q are integers and Q not equal to 0. Since we don't know what 0.3 bar is, let us call it as x. So we can write let x is equal to 0.3333 etc. and let this be equation number 1. Since after this decimal point, since only one number is repeating, when one number is repeating, we multiply it with 10. If two number is repeating, we multiply it with 100. If three number is repeating, we multiply it with 1000. So keep this in mind because this type of questions are very important. So if you understand the method, it will be very easy for you to do, and it's sure for your exams. Okay. So we'll multiply this equation 1 by 10. So the first equation will become 10x is equal to 3.3333. That is equation number 2. How it became 3.333? When you multiply with 10, it will this decimal point will go to right side. One number to the right side. Okay. The next step, we have to subtract. Subtract 1 from 2. So 10x is equal to 3.3333 etc. Then x equal to 0.333 etc. Then you subtract it, you will get 9x is equal to this part will get cut and we'll write equal to 3. Therefore, x is equal to 3 by 9, and when you do cancellation, this will become x is equal to 1 by 3. So this is our answer. I hope you understood because it's very easy. Once you understand the method to do, you can do any questions related to this. Okay, so let us go to the next page. Show that 1.272727 etc. is equal to 1 0.27 bar can be expressed in the form P by Q, where P and Q are integers and Q not equal to 0. So here let x equal to 1.272727 etc. and let it be equation number 1. Since two numbers are repeating after the decimal, we will multiply equation 1 by 100. Okay, so this will become 100x is equal to 127.2727 etc. and let this be equation number 2. Then subtract 1 from 2. Then we'll write 100x is equal to 127.2727 etc. minus x is equal to 1.2727 etc. So make sure when you're writing this, put the decimal part like in means exactly down this part. So it will be easy for you to cut like this. Okay. Then we can write 99x is equal to 126. X equal to 126 divided by 99. After cancellation, you will get 14 by 11. So the answer we are getting is x is equal to 14 by 11. I hope you understood this part. Okay, next, let's go to the next page. Okay, now look at this question. Here you can see show that 0.2353535 etc. equal to 0.235 bar. Over here, the 3 5 is repeating. So there is a bar on top of 3 5. Can be expressed in the form P by Q, where P and Q are integers and Q not equal to 0. Okay, this is a question. Like I said before, this type of questions are very important. So make sure you study the method. Like they won't be asking you the exact same question, but similar to this type you will be getting for your exams. Okay, what should we write? Let x equal to 0.2353535 etc. and let this be equation number 1. Then since two numbers are repeating after the decimal point, we have to multiply this with 100. Multiply equation 1 by 100. So the equation 1 will become 100 x equal to, then the decimal point will go to right side, two numbers to the right side. So it will be 23.53535 etc. And this is our equation number 2. Next, we have to subtract equation 1 from equation 2. So it will be 100x equal to 23.53535 etc. minus x equal to 0.23535 etc. Now subtract it. This will become 99x equal to 23.5 minus 2 is 3. Then this part you can see this all are similar. That will get cut off. Okay, or 0 0. So this can be written as x equal to 23.3 divided by 99. Then to remove this decimal from this number, we multiply it with 10, and when you're multiplying the numerator with 10, you have to divide it also with 10. So this will become 233 divided by 990. So the value of x is equal to 233 divided by 990. Okay, is this clear? Okay, now let us go to the next page. Find an irrational number between 1 by 7 and 2 by 7. So in this question, we have to find the irrational numbers between 1 by 7 and 2 by 7. For that, first we have to do the division. Okay, we have to do the division to find the decimal expansion. So we'll put the decimal point here, it becomes 0, then 1, 7, you will subtract, you'll get 3, then 0 will put, then 4, this will become 28, minus, here you will become 2, 0, then 2 over here, it will become 14, you subtract 6, 0, then write 8, this will become 56, subtract 4, 0, then 5, which gives 35, subtraction 5 here, 0, then 7 sevens are 49, subtraction 1. See, you are getting 1 here, that means it is again going to repeat after this particular calculation. So we'll write 1 by 7 is equal to 0.142857, this whole bar. Since after this number it's going to repeat, then we have to find the division, like decimal expansion of 2 by 7. How do we find? We don't need to do the whole division. We can just simply write 2 into 1 by 7, which is very easy. Like 2 into 1 by 7, the answer you have already found. So 0.142857, the whole bar. Now we have to do the multiplication part. 0.142857 into 2, and this whole bar is there. Then 2 into 7, that is 14. 2 5s are 10. Then plus 1, 11. Then 2 8s are 16, 17. 2 2s are 4, plus 1, 5. Then 2 4s are 8, 2 1s are 2, point, and this 2 into 0, 0. You get the answer as 0.285714, the whole bar. Now I'm going to write the decimal expansion of 1 by 7 over here. That is 0.142857, this whole bar. And the decimal expansion of 2 by 7 over here, that is 0.285714, the whole bar. And we have to find the irrational number of this two. Between this, we have to find the rational number between these two decimal expansion. For that, now look at this one. It is 14 over here and it is 28 over here. The numbers between these two are 15, 16, 17 till 27. So you can write any numbers between this, like 0, if you are taking 15, 0 0.150, 1500, 15000, and it keeps on going. That means here a pattern is formed. And for it being an irrational number, it will be non-terminating, non-repeating. Okay. So here you can see this pattern form. It is non-terminating and non-repeating. Okay, you can take other numbers as well, as like it should be less than 28 and greater than 14. So you can take even 27, 0.27, like this. A pattern is forming, and here the numbers are not repeating. So these are the irrational numbers between 1 by 7 and 2 by 7. I hope you understood and this part is clear. Okay, now let us go to the next page. Operations on real numbers. Operations here means addition, subtraction, multiplication, and division. So these are the operations on real numbers. See, first add and subtract. In that addition, one question is there. Add root 2 root 2 plus 5 root 3 and root 2 minus 3 root 3. This you can write as first we have to write the step 2 root 2 plus 5 root 3 plus, because here it said add, plus root 2 minus 3 root 3. And one very important step is that we can only add with the same root. Okay, here root, so we are just arranging it correctly. 2 root 2 plus root 2 plus 5 root 3 minus 3 root 3. Now, see, 2 root 2 plus root 2 means 3 root 2 plus 5 root 3 minus 3 root 3 is 2 root 3. So this is how we add. Next question, multiply. Multiply 6 root 5 into 2 root 5. So we can write 6 into 2 into root 5 into root 5. See, one identity, like we have studied root a into root a is equal to a. In your previous class, you must have studied this. Root a into root a is equal to a. So if the number in the root are same, when you're multiplying those two, it will become, you just need to write the number itself. So this will become 12 into 5, which is equal to 60. But whereas in case if the roots are different, so suppose it is 6 root 2 into 2 root 3. Okay, so how will we write? We will write this as 6 into 2 into root 2 into root 3, which is equal to 12 into root 6. 12 root 6. This is the answer. We'll multiply the numbers. The 2 into 3, which is equal to 6. I hope this part is clear. Next, division. 8 root 15 divided by 2 root 3. This, on the numerator part you can see 8, denominator part 2. We can do the cancellation like taking the 2's table. This is 1, this is 4. Okay, then in the root part, here it is 15 and here is 3. When we can cut it, this is 1, this will become 5. So the answer is 4 root 5. It's very easy. Now let us go to the next page. These are some identities which are very important in this chapter. That is, the first identity is root AB is equal to root A, root B. Second one is whole root A by B is equal to root A by root B. Third one is root A plus root B into root A minus root B is equal to A minus B. If you by heart all these identities, it will be very easy to do the problems. Okay, the question part will be very easy. You can just substitute this identities. A plus root B into A minus root B is equal to A square minus B. Fifth one, root A plus root B into root C plus root D is equal to root AC plus root AD plus root BC plus root BD. And the sixth one is root A plus root B the whole square is equal to A plus 2 root AB plus B. Now let us go to the next page. Simplify the following expression. 5 plus root 7 into 2 plus root 5. So in this one, how can we write? Multiplying 5 into 2. 5 into 2 plus 5 into root 5. Then plus 7 into root 7 into 2. We can write it as 2 root 7 plus root 7 into root 5, which is equal to 5 into 2, 10 plus 5 root 5 plus 2 root 7 plus root 35. This is the answer. Very simple, right? Next question. 5 plus root 5 into 5 minus root 5. We can use the identity. Which identity we can use? A plus root b, a minus root b, which is equal to a square minus b. So this we can write it as 5 square minus 5, which is equal to 25 minus 5, which is equal to 20. This is our answer. I hope you understood. Now let us go to the next page. Next question. Root 3 plus root 7 the whole square. We can even write this as a plus b the whole square using this identity, which is equal to a square plus 2ab plus b square. So the answer will be root 3 the whole square plus 2 into root 3 into root 7 plus root 7 the whole square, which is equal to root 3 into root 3 is 3 plus 2 root 21 plus 7, which is equal to 10 plus 2 root 21. Okay, now next one, root 11 minus root 7 into root 11 plus root 7. This can be written as root 11 the whole square minus root 7 the whole square, which is equal to 11 minus 7. The answer is 4. I hope you understood this part. Now let us go to the next page. Next topic, rationalize the denominator. The question, rationalize the denominator of 1 by root 2. 1 by root 2 we have to rationalize. The method we do is, see, the denominator we have root 2 here. We take this root 2 and we multiply on the numerator part and denominator part. Now if you see, it will become root 2 divided by root 2 into root 2, which is equal to what? Root 2 divided by 2. Like I told you before, root a into root a is equal to what? A. This is an identity. So the answer here is root 2 by 2. This is our answer. Next question. Rationalize the denominator of 1 by 2 plus root 3. In this question, if you see, like I said before, we have to take the denominator part and then multiply on the numerator and denominator. But when you have this operator like plus or minus, it will change. See, in this question, 1 by 2 plus root 3 multiplied by 2 minus root 3 divided by 2 minus root 3. The sign changes here even though we are multiplying on the numerator and the denominator. So this will become 2 minus root 3. And this is 2 plus root 3 into 2 minus root 3, which is equal to 2 minus root 3 by a plus b into a minus b. What is it? A square minus b square. So here it will become 2 square minus root 3 the whole square. So I'll just write the identity here. A plus b into a minus b is equal to a square minus b square. Now our answer is 2 minus root 3 divided by 2 square is 4 minus 3, which is equal to 2 minus root 3 by 1. That we can write it as 2 minus root 3. So this is our answer. I hope you understood. Now let us go to the next page. Next question, that is rationalize the denominator of 5 by root 3 minus root 5. For this, again, when you're rationalizing it, you'll take it on the numerator part. Then here the sign changes, it will become positive. Then denominator part with the same number with the sign change. You can write this as 5 into root 3 plus root 5 divided by root 3 square minus root 5 square, which is equal to 5 root 3 plus root 5 divided by 3 minus 5, which is equal to 5 root 3 plus root 5 divided by minus 2. I hope you understood. Let us go to the next page. Rationalize the denominator of 1 by 7 plus 3 root 2. 1 by 7 plus 3 root 2. So we multiply it with 7 minus 3 root 2 divided by 7 minus 3 root 2, which is equal to 7 minus 3 root 2 divided by 7 the whole square minus 3 root 2 the whole square, which is equal to 7 minus 3 root 2. This will become 49 minus 9 into 2. This is equal to 7 minus 3 root 2 minus 49 minus 18. And this equal to 7 minus 3 root 2, 31. So this is our answer. Now let us go to the next page. Laws of exponents for real numbers. See, laws of exponents for real numbers, you have also studied this in your previous grades. So these laws are not actually new for you. See, a raised to m into a raised to n is equal to a raised to m plus n. Here when it is multiplication, in this if here you will get as plus sign. Okay. Here if you look, the bases are same, the powers are different. So you add the powers, writing the base as same. Second one, a raised to m, the whole raised to n. You will write it as a raised to mn. M and n you will multiply. Okay. The third one, a raised to m divided by a raised to n is equal to a raised to m minus n. The base are both same, the powers are different. So you'll write the base same and subtract the power where m is greater than n. The fourth one, a raised to m, b raised to m. If you look here, the powers are same, the base both are different. So you'll write this as ab the whole raised to m. Okay, that means you'll multiply this ab and write the power as it is. AB the whole raised to m. Now let us go to the next page. Simplify the first question. Simplify the first question is 2 raised to 2 by 3 into 2 raised to 1 by 3. So the according to the law, we can write this as a raised to m into a raised to n, which is equal to a raised to m plus n. So what is the answer you can write for this? This is equal to 2 raised to 2 by 3 plus 1 by 3, which is equal to 2 raised to, here the denominator part is same. So 3 and 2 plus 1 is 3, which is equal to 2 raised to 1, and the answer is 2. Second question, 3 raised to 1 by 5 the whole raised to 4, which is that law, the identity a raised to m the whole raised to n, which is equal to a raised to mn. So this we can write it as 3 raised to 1 by 5 into 4, and this is 3 raised to 4 by 5. This is our answer. Hope you understood. Now, let us go to the next page. Third question. 7 raised to 1 by 5 by 7 raised to 1 by 3. Which is the identity used here? A raised to m by a raised to n, which is equal to a raised to m minus n. And the answer here is 7 raised to 1 by 5 minus 1 by 3, which is equal to, see, the denominator part is different. So if you take the LCM of 5 and 3, what you're going to get? You will get 15, right? 3 into 5, which is equal to 15. Here, if you multiply with 3, then the numerator also you'll be multiplying with 3. So here it will be 1 into 3 is 3. And if you're multiplying over here 5, this is also 5. Here it will become 5. 7 minus 2 by 15. This is our answer. Got it? Now the fourth one. What is the identity over here? A raised to m into b raised to m, which is equal to ab raised to m. So here the base are different. 13 into 17, the whole raised to 1 by 5, which is equal to, when you multiply 13 into 17, you will get 221, the whole raised to 1 by 5. This is the answer. In the next videos, I'll be doing the exercise part. So each exercise will be done in a separate videos. So thanks for watching, and please do like, share and subscribe my channel. Thank you.